Hey, this is Greg again, and this is part 4 in my series on building a heavy-duty 2x72 belt grinder. It's based on Phil Vandelay's design that I'll link below, with several changes for imperial dimensions and materials, and a different way of doing just a few things. If you haven't already seen the part 3 video, you should watch it first. I did the machining of the main plate, the attachment arm, and the attachment sleeve in that video. At the end of part 3, I'd promised that this part 4, I'd be building a tensioner arm, tensioner wheel, and I will be doing those here. But I also promised this tensioner release lever, and I won't be doing that, as I'll explain later. Instead, I'll be making this fairly detailed and precise machine table clamping block that bolts onto the attachment arm and clamps this rotatable main table arm. It's a pretty long video as I ran into a few snags and fixes along the way. I'll go through the machining of each part in turn, but just to wave some generalities around, almost every machine part involves the same basic steps. Cutting off a hunk of metal using the bandsaw, a little larger than needed. Squaring up that hunk on the mill while bringing it to final dimensions. Using edge finding or center finding to locate any needed features on the DRO. Machining those unique features that this part requires. Often some chamfering or rounding to make it pretty. There's always plenty of deburring. Plus lots of time cleaning and vacuuming up all the metal debris that spews everywhere. I swear I spent half my time in the garage just cleaning up from the previous operation. So you'll see these same basic steps over and over during the video, and pretty much every other YouTube machining video. I'll greatly speed up the mundane footage and skip the deburring and cleanup so I can spend more time on the important, unique features and the decisions made along the way. So let's get on with it, starting with this tensioner arm, also sometimes called a tracking arm. The two terms are used interchangeably. So here's what we have so far. The main plate with its sleeve and its sliding rod, which turned out very nicely, nice close tolerances. I'm not quite as happy with the tolerances of this. I definitely have some at least 2,000 shake there. I was sneaking up on the dimension, and then as I always do, I snuck up too much. I said, oh, I can take a bit more, and ended up too much. Paint will have some thickness to it, and we'll see how that takes up the slack. In any case, I don't think it's a big deal once it gets greased up and tension rod on there. It's gonna be fine. Then on the top end of this, that's the bottom there you're looking at. On the top end of this, on the other side, will be this wheel, and you see there's quite a cup in that wheel there, which I got this big hunk of metal lately from eBay, and that'll actually fit inside here. I might take off a couple of corners just to make it fit better, but that'll help me make this bracket that's going to pivot on here to hold onto this wheel, just a small piece of it. I have to obviously cut this down too into the proper shape to get a bolt through there, through the bracket, as per the plans, but I think that's going to work out well. And I'll also use that big hunk of metal to form the clamp down here that holds on to this big 1.5-inch rod here. Okay, that's the main rod, that's the main supporting rod. Now I was going to, original plan here, I've got a lot of this, original plan I was going to whittle this down in my lathe to 1 inch, but I actually, it's just really tough stuff. And so I bit the bullet and just went out and bought some inch stainless steel as well. So that's what I'm going to use. This is 16 inches long, which is perfect for the table support rods. One comes horizontally, one comes vertically, about 10 inches and 6 inches, and so that's perfect. And then the offcut from when I took this piece here off the huge piece of 3/4 inch, right? I cut it here and then I cut it here off of there. horribly ragged cut that I have to clean up, obviously, but that's going to be the main table. That's the proper size for the table. Just a little side project that came up. This is the misting arm from my mill. And I don't know how I abused this thing, but somehow I snapped off the little plastic fitting that goes into the main plate here. I was originally going to make one of these things out of metal. I thought it'd be a cool project, but I couldn't think how I was going to accurately make this ball end on it. I don't have a ball turner, and it just seems like a bit too much work. And I don't expect this is going to break again. So I just ordered from Amazon a whole set of these things for, I think it was like $9 for this whole set. So I'll have 9 ends. These ends appear to be the same, that will fit into the same click connect thing here. So hopefully that will work out. And I also removed 3 of these click connect things because this arm was just too long. It was sort of always in the way of the quill handle. So I think this will work out better. So let me get one of these out of here and see if it will indeed fit. Have high hopes. My $9 repair is going to work. So I'll pop one of these off. Oh, always hard to get off. There we go. And it should fit in there. Yep, indeed. Perfect fit. And I know the thread's the same for that, so we're good. I just have to shorten this tube a little bit and then put it back together, and I should be good to go. So it's back together again, went together easily. Just to show you, I put some JB Weld epoxy on here, some quick setting JB Weld, because I think this is a weak point. I don't want it to break here again. I don't need that last knuckle to flex anyway. I've got plenty of adjustability anyway. So as soon as this hardens up, I'll put it back on the mill. So let me take a few minutes to try to explain my thought process here in real time for this bracket. Again, this bracket is going to be supporting the wheel on the main plate tensioner arm out here. So for starters, this has to get milled away. I'm deviating from Phil's design a little bit, leaving a little top plate on here. That'd be nice and strong. So I'm going to mill away this section out of here so that this will fit neatly on top of this little pillar right here. This is the tensioner arm, right? So it'll pivot here. And I've sort of marked on here where the approximate pivot's going to be just by sighting it on here. I don't know if that's going to show. But basically I need a little bit of clearance at the front here so this can tip, and a little bit of clearance at the bottom so it can tip. Might have to round over those shoulders. We'll see when we get there. Can always make some fine tuning afterwards, but that's where the center is going to be of that pivot point. And then I also have to be conscious of the fact that the wheel, am I showing view here? Yeah. That the wheel has to space off the faceplate just a little bit, right? There's going to be a big wheel here that's going to be spaced off the faceplate on the motor, and this wheel has to be spaced off to line up with it. So figure doesn't have to be much. That's plenty of spacing. So if I put that on here, I zeroed my depth gauge here and then measured to that center of that hub. That's where I wanted to rest my part on. And it's 875 exactly, which is kind of a convenient 7/8 of an inch. So this thing has to sit away 7/8 of an inch away from the faceplate here, right? So here's my piece of metal. And Phil's design again suggests, and I'm going to go along with it, that the pivot point here, if I transpose out to the end, that the wheel should pivot 1/2 an inch below that. And that's by design. It has to maintain tension on this thing for the back screw that's going to press against it. So roughly like that. That's going to mate up with here. I've got a 10-degree, very subtle angle on this. Really, I'm sure I could get away with nothing at all, but it's better to have a little bit of angle on it. Come back and clean it up. So I had this idea about how to get a good, accurate center for where I want this pivot. And basically, it's a 10mm hole. I got a 10mm transfer punch here I'm going to use as a pivot. And then I can just set it down about where I think it should be, and then experiment with it. Because I've got the shoulders on this piece. As long as I keep this vertical, I've got the shoulders on this tensioner rod. I mean, I'd rather err on the side of not enough space, because I can always mill away some more metal here on the piece, if need be, rather than making it a sloppy fit. So I think right about there gives me a perfect amount of motion. It might be a little tight on the front, but again, I can mill that away if I need to. So I think if I had a hammer handy here, I would give this a whack. Of course, I don't have a hammer, but I'll repeat this again in a moment, off camera. So now I've got that whole center position center punched. I can use that as a reference. So as I was saying before, I'm sure my hands are going to be in the way for most of this shot. I want to go down, I die camed up the whole thing here. So I want to go down 1/2 an inch from that point for the center of the boss here. It's going to have the bolt going through it. There's center right there. And I'll use my DRO to get the accurate center here, but I'm just going to mark it for visuals right now. Approximately there. But for now, I'll just scribe right on it for visuals. And I'll measure it with a DRO when I get to that point. And I intentionally made this piece a little thicker because I want to leave the top cap on. I think that's going to look cool and add a little strength as well. Not that it really needs it, but every little bit helps, right? So that will accept that boss in there when I mill that out. But I'm not going to do that yet because it's going to help me to hold this in the lathe with that thing intact. So a slight change of plans. I've got my circle on there. I'm still going to drill through it, but rather than using the 1/2 inch final bolt, I'm going to use this 10mm, a little smaller, so I won't have to worry about messing up the threads when I do the final hole. So it's good 10mm hardened bolt. So I'm going to find the center here and then drill it out in steps to, let's say, 9.5, and then ream it out to 10 to get a nice tight fit on this to fit in the lathe. So let's find the center first. Seen this a million times, I know. And this 1/2 inch down isn't critical. I'm just eyeballing it here where my center is there. I'll do it better with a drill in place. I just realized I got to move this because I don't want to drill into my vise, do I? How stupid of me. I got to put it over here in the center instead. So I won't lose my Y and the X I can eyeball again. That looks centered. Now I'm just going to remove excess material around there, around that circular feature, so I can save myself some time on the lathe. So now these bolts for the axle are half 13, and if I consult my chart here, I don't think you can see it, but half 13 in steel needs a 29/64 drill, which I don't have. One size down is 28/64, which I have, and I've got one size over, so obviously I'm going to go one size down. So it's 7/16. Okay, so now I've cut my bolt off, so it shouldn't protrude out the back side of this L shape anymore. And I've bored the, counterbored it enough to hold that shank. And now let's give this a test. But that's good, and there's no slack whatsoever. There's a retaining C-clip on here that the washer rides crooked on. I think I need to trim off my washer a bit. A smaller washer on there would be better. All right, new fit. Perfect. No slack. Perfect, perfect, perfect fit. And I just need to trim off these shoulders a bit to clear. Okay, so what I did is I put this in some soft jaws and used this nice little Makita thing with a grinding burr on it to get down in those corners and square them off pretty well. And it's not beautiful on the inside, but nobody's ever going to see it in there once it's put together. And now this piece here fits in there nicely and has the appropriate amount of rock to it. Once I put that hole through the center, and it's very, very tight. So I've laid out what I've got here so far just to explain what I'm doing next. A little change of plans again. In my previous video, I had promised that I was going to build what I've built there so far, this bracket, as well as the gas strut and the tension release arm here. But I'm going to not do this right now, and I'll explain why. I'm going to change the design, Phil's design again. Rather than releasing the tension, I'm going to have my arm, just mocking it up here, applying the tension. Okay, so I can do that from this side. I can put a pivot point about there and have this arm applying the tension to the gas strut and locking in place. So the opposite of Phil's. I think that's going to be easier to work with. You can push down on this a whole lot easier than you can pull up on it in practice. We'll see it. I'm not saying it's better. I'm just saying it's different again. But because of that design change I'm going to make, I'm going to not do this now because I need to get some more together to see how long I actually need to make this whole assembly. So I'm going to set this aside for now. And instead, as part of this video, make this table clamping block, the main block here that holds this big rod, a little bigger than in Phil's design. I've got an 1.5 inch stainless steel rod here. And basically, I need to cut a circular feature in here that this rod is going to clamp into. So now I've clamped those two pieces together and put them in my vise and some soft jaws. It's kind of hard for me to get down here with the camera in the way. The 6mm drill bit was just horribly dull, and when I saw the other side of this piece, it had obviously wandered off quite a bit in several directions. The 6.5 was much sharper and it went true, but when I was drilling with the 6, it was definitely, I should have replaced it earlier. So rather than counting on my DRO to mark these holes that they're at the top surface, they're not the same on the bottom. So I'm going to use a transfer punch here. Okay, I'm definitely not proud of this, but you got to do what you got to do. I don't want to scrap this part. They say the holes on the bottom side of this are not square. So I think the best way to do it, I've got the two front ones went in square because there's not much distance for them to go. So I've got them in properly and everything aligned. And now I think my best approach here is just to drill these holes through top and bottom to make sure this drill stays aligned with the actual angle that the holes are at for the tapped holes on the bottom. Again, no one's going to see this when it's done, but I think this is the best way to save this part. Oh, don't need So that's 5.5 tapping size. I think I'm actually going to take it apart now, tap that hole, hold everything more securely to let me do the other ones. Okay, now with the, I took it apart, tap that hole. Now I've got 3 in here to hold it nice and securely. Now I can go ahead and drill my other 3 directly through. Those are all torqued down. I've got all 6 of them in there. Good and strong. Some of this can be. So I caught myself just in time before I made another silly mistake. I mentioned earlier that I was going to offset that 1.5 inch diameter rod a little to the top of this clamping block just to give more meat for the clamping bolt down here. But in fact, I can't do that. I realized just in time that as this thing, there are some permutations of this table where you might have this all the way back or that table rod slid back. And when it is slid back, it needs to be able to clear the bottom of this plate here. So that's just shy of a 1/2 inch thick, 1.4 after it's milled down. So I had to allow 1.4, 1.5 here clearance. So I had to move, that was my original center hole on this clamping block. I had to move it down to this new center hole. So I've got enough clearance with a 1.5 inch tube. Okay, so I'm gonna go cut my hole in here now. I'm sure you've all seen this technique a million times on many other YouTube channels, where you put a dead center in between your live center and your center point, and then indicate on it, on the big end of it, so you can detect some very small run out here with this technique, and then dial in the 4-jaw chuck as appropriate. I've got this down to about 2 thou, which honestly is a whole lot better than my center point mark is, accuracy-wise, and plenty good for this job right now. Okay, this is just figuring out how far I dare move my carriage in before I crash against the jaws here, which is right there. I've set my DRO to 0 right there. And then I've had to stick out my boring bar here just enough to reach the front face of that chuck, which is the rear face, of course, of my part. So that should do it. I don't like to have that much stick out, but you gotta do what you gotta do. Okay, it's late in the evening, and just the final thing to do is the final assembly of all this stuff I've made. I've already bolted on my wheel onto this bracket here, and it spins nicely. I had to chamfer the bracket a little bit to clear the shoulders of this part of the arm, but it does clear nicely now. And I already showed I cut a few more threads on this bolt here, so it's perfect length. So this arm will ride completely on its shoulders in here. I'll sheet here and use a power ratchet. Dropping stuff all over the place. Okay, so that has, oops, take this adjuster rod out. So that's got about 10 degrees down. If I need more, I can always mill away this angle a bit more to let it come down a little bit further. And it's got plenty of up, at least 20 degrees up. But it really only needs about that much, honestly, from 90. And then this is a 12 millimeter threaded rod that I just had left over from my work on the bandsaw. And I still need to make a knob for this, and I'll make a knob exactly the same as I made for my bandsaw earlier. You can check that video. I'll just make exactly the same knob here. It worked out well. So that's that. And that, of course, slides into this piece. Okay, there we go. So that sort of shows that movement, right? And it has the right amount of clearance from the front face there that I needed. I'll just adjust this wheel here to suit that wheel now. And then this piece here, I've got these little ball retainers in here positioned, and they're thread locked in with the retaining compound, and they should be good and set now. So now I can put this on here. I know that's the front and that's the back. And it does matter because, again, my screws here aren't perfect. So it is directional, unfortunately. Again, I'll cheat and use a power driver. Put these front ones in loosely at first. And then the middle ones. Set the rear ones in there too so I can do them all at once. There we go. All right. And that's that. And then my big rod, it's harder to get in now that these balls are in here. Still a to-do per Phil's plans I just got my ball end mills in today to the length of this, put a nice depression in there, ball end at 0 and at 90 degrees. Phil suggests to let this thing rotate 0 and 90 and index into that thing. But even with those balls in there, of course, you can still get this in there. It's just harder. There it goes. There it goes. And with the table on here, you'll still be able to turn this. I already tested it, and I can turn it. It's just that it's very stiff with those balls, but it does turn. And then, of course, my locking levers. Yeah, right in that position when they're locked. And that position when they're open. Okay? And then, of course, this whole thing slides in here. And we have a complete assembly thus far. So that about wraps it up, finally. It's been an adventure, honestly, on this thing so far. But I'm still happy with it. And we got some serious weight here now. I know, I guess that's probably 41.4 pounds right now. All right, that's enough for now. Signing off.